Hello guys, today we will see how we can implement distance relays in Etap. On the screen you can see a simple single line diagram. I have two transmission lines connected in between the source and the sink or the load. So this is the transmission line 1 and here this is the transmission line 4. Okay, so here this is my distance relay, this is the circuit breaker. This circuit breaker will be operated when this protection is triggered, and I have the VT input and the CT input for the distance relay. Okay, so this distance relay you could get it from here. The ANSI code 21 is for the distance relay, or you could use the multifunction relay. Let me open my CT. So the CT rating is 200 power 1. Okay, so 200 power 1, and this is the VT ratio. The VT ratio is 110 kV to 110 volt. So the ratio is 1000:1. Okay, now let me run a simple load flow analysis. Okay, load flow analysis went well. There is a voltage alarm over here. We will ignore this right now. Let us go about configuring the distance relay parameters. Double click on the distance relay. This is the window which pops up. We will go directly to the *Z distance. Okay, the first thing which I will do is to select a suitable relay. Here you have the library information, so select on the library. So you will have many manufacturers available on the Etap library. So I have selected the Schneider Electric and the model is P441. You could select any other model. The only thing you should remember is that it should have the distance function. So the relay which I have selected is the Schneider Electric P441, and then I will go to the input tab. In the input tab you can see that the relay input current is CT1, the primary and the secondary amp turns is shown here. Then the voltage tab. In the voltage tab you can see the PT input is the 3-phase 110 volt AC. On the digital tab you can see this is the digital input. So the digital input is the HVCB status. So HVCB, if you select the HVCB, the ID is CB1 and the input will be the status. If you want to add another digital input, you can select add and select the HVCB status, or you could select anything else from this relay, LVCB, relay, SPST, or any other status which is available in the drop down menu. Okay, then the base. So the base is the device ID 1. In the output tab you can see here I have a output ID. So my output ID is D01 and the relay element is logic, because the distance element is in the logic portion. We will discuss more about this in the scheme logic. So my output ID is D01. You could add another output ID by just clicking on the add new digital output and select any other element that you want. Okay, then after selecting the output ID you have to go to the interlock portion, and you know your output ID is D01. Then add new interlock, select the HVCB, your device ID, and the action in this case is open. Okay, so here I could not add any more because there is only one HVCB in my case. So the next tab is the overcurrent tab. So in the overcurrent tab you can see this is the overcurrent and this is the instantaneous. For this example I will be disabling both overcurrent and instantaneous portion. Okay, the same for fault element also. Then we have the overload and thermal overload also I will be disabling in this case. Okay, so then we will go back to the start the distance. So here we have the setting base. The setting base, you could select the primary values, the secondary 1 amps value or the secondary 5 amps value. Here I will be selecting the primary value. Primary value will be entered here. If you are going to provide the secondary values, you have to convert your primary values to the secondary value using the CT to VT ratio. Here you have all your categories available, so the line setting, zone settings and other parameters. Okay, the first thing we will do is the line setting. So I have already calculated everything in an Excel sheet. So this is my Excel sheet. Okay, so this is the CT ratio, this is my VT ratio, so this is the impedance ratio. If you are going to convert it from the primary value to the secondary 1 amp value, you need to divide using the impedance ratio. The line length, okay, I forgot to mention the line length. Here in the transmission line, you can see this is my transmission line. So this is a Pirelli AAA, and the length of the transmission line is 50 kilometers. Okay, so going to the impedance tab, in the impedance tab you can see this is the impedance of the transmission line. So here I have my positive sequence impedance, negative sequence impedance and the zero sequence impedance. So this is given in the form R plus JX. So this is the reactance portion of the impedance. If you want to change it from ohms per kilometer or the ohms itself. Okay, so you need these values in order to calculate the impedance in the distance relay. So this Y portion is the admittance portion. So here for this example we don't need this admittance portion, we will only consider the impedance portion, that is the R plus JX, where R is the resistance and X is the reactance. And for this transmission line, this is 10 kilometers in length. It is the same Pirelli AAA conductor. The impedance is also here. So positive sequence, negative sequence and the zero sequence. Okay, now for the circuit breaker I have selected the Cutler hammer. Okay, you could select any circuit breaker. For this example it doesn't matter. Okay, now coming back to the calculation portion. So the impedance per kilometer, so this value I have got it from the transmission line editor, ohms per kilometer. So this is the impedance per kilometer. Okay, so this is the impedance per kilometer. This is the positive sequence, negative sequence and the zero sequence resistance values. This is the reactance values. Okay, so these are in the Cartesian coordinates. I have converted it into polar coordinates. Okay, so for this you will use this equation, which is the square root of r1 square plus x1 square. So this gives the impedance z1, and for the angle you use tan inverse x1 by r1. The total impedance of the transmission line is the per unit impedance in kilometer into the line length. So line length is 50 kilometers. If you change it here, you can see the impedance varying. Okay, so this is the total impedance of the transmission line. This is the positive sequence, negative sequence and the zero sequence. Okay, and this is the zero sequence compensation factor. In the previous lecture I have already mentioned what the zero sequence compensation factor is. So zero sequence compensation factor is used to translate the positive sequence, or to translate the zero sequence to the positive sequence value. Okay, so this factor we need to provide. Okay, so this is the zero sequence compensation factor, star Z portion, and this is your zero sequence compensation factor. z0 minus z1 by 3z1. So this is already calculated here. Okay, for the forward, so for this case I have considered 4 zones. Okay, so in the 4 zones I have the first zone in the forward direction. So the forward direction is, this is my forward direction, that is towards bus 2. Okay, so in the forward direction I have selected 60%. So the 60%, this is the impedance value. So this is the 60% of this positive sequence impedance, and this is the 60% of the positive sequence reactance. Similarly, 60% of the positive sequence resistance. This is the 60% of the zero sequence resistance. Similarly, for the forward 100%, this is the zone 2. My zone 2 is 100% and my zone 3 is 120%. And for the zone 4, the zone 4 is the reverse zone. Okay, so this is the reverse zone, and in the reverse zone I have selected 30%. You could vary it depending upon your specification. So here if I change to 5%, so these are the values. Okay, then if you go to the star Z distance tab, you can see the line angle. So the line angle, you have to enter this value from the calculation sheet. So the line angle is 23.05. I have selected 24. Okay, then the next is the zone status. I have selected 4 zones. So here if you see here, this is the first digit. First digit is zone 4 enabled. Zone 4 is enabled, and bit 4 is zone 3 enabled. Okay, zone 3 is also enabled. Zone Q, zone P, both zone Q and zone P is disabled. Then next you have zone 2 enabled, so zone 2 is enabled, and then last digit is zone 1 extension. So zone 1 extension zone is disabled. Here we have selected zone 1, zone 2 and zone 3. Okay, zone 1 extension is disabled, zone P enable is disabled, and zone Q enable is also disabled. So zone 1 is enabled as a default. You cannot disable the zone 1. So here KZ1 RES compensation. This is the zero sequence compensation factor. So the zero sequence compensation factor is calculated here. It is 0.363. 0.363. The angle is 24. Okay, so the angle is 24. So zone 1 impedance. The zone 1 impedance is the value here. So this is 28. Okay, here we have 28, and this one is the zone 1 positive sequence reactance. It is 10. Okay, 10.9, and here this is the positive sequence. This is the positive sequence resistance, so 25.77, and the last one is the zero sequence resistance, that is 30.09. Okay, I have selected 30.09, and this portion, this is the TZ1. This is the time for zone 1. So zone 1 time I have selected 0 because I want it to trip instantaneously. Okay, and similarly you have to provide the values for KZ2. This is the same compensation factor, just use the same values, 0.363. okay, KZ2 angle, Z2, R2G, R2PH. This is the time for zone 2. So this time for zone 2 is 0.2 seconds, and this is the 3 and 4 compensation factor. This is the same value, 0.363, and the angle is 24. And here we have the time for zone 3 is 0.6, and the time for zone 4 time is 1 second, where the zone 4 is in the reverse direction. All parameters are already set. So we have other parameters. This is disabled So these are Z1M tilt angle. So the tilt angle and everything, we'll just keep it as 0 for this example. And then the next tab is the scheme logic. So in the scheme logic, you can see here on the left side, there are several variables. You have the protection element, the inputs, the timer, output, slash, etc. So in the output portion, you can see this is our output ID that we have created here. Okay, so going here to the output ID, select your output ID. Okay, select your output ID. I will delete and show as an example. Okay, select your select your output ID, and in the logic expression you have to select the distance trip. Okay, what this means is when distance trip occurs, an output will be given to the output ID D01. So this output ID is going to operate the circuit breaker. So from the scheme logic, you can see there are several protection elements you could use to develop multiple logics. Okay, and you can also use the inputs. So this is my input DI1, which is the HVCB status. You could use this input to generate any other output and operate any other device. Okay, if you need to initiate breaker failure, you could use these elements, like this is the start element, like zone 1 start element I can use. And I could also check if my circuit breaker is still closed, then I will initiate another output which will operate a different circuit breaker. Okay, so this is how the scheme logic works. Okay, so after this you have to save all of your configuration of the relay. The distance relay configuration is now complete.